Hello everyone, I am Dr. Janavi Chakrabarti, Assistant Professor, Department of Mathematics, Bardhaman College of Engineering. Today in this video, I am going to discuss the numerical solution of first order ordinary differential equation using Picard's method. Now let us see what is Picard's method. For this method, first of all we will consider the first order ordinary differential equation which is given by dy by dx is equal to f of xy, and the initial condition is at x naught y value is y naught. Now we need to solve this equation, that means we need to find y of x. In this method we get successive approximations by integrating this equation. So by the Picard's method, the sequence of approximation is given by nth approximation of y is equal to y naught plus integration x naught to x f of x n minus 1th approximation of y dx. We will repeat this process until finding this integration is not difficult. If it becomes difficult to find this integration, then we stop the process. This Picard's method can be applied only to a limited classes of equation in which successive integrations can be performed easily. Now let us see how we can derive this sequence of approximation. First of all, we will consider dy by dx is equal to f of x comma y, and y at x naught is equal to y naught. Now this equation can be written as dy is equal to f of xy dx. Let us give this equation number 1. Now we will integrate this equation 1 between x naught and x. Integrating equation 1 between x naught and x, we get integration x naught to x dy is equal to integration x naught to x f of xy dx. Now this this will be y of x and limits are x naught to x, and here it will be integration x naught to x f of x y dx. Now let us put the limits. We will get yx minus y x naught is equal to integration x naught to x f of xy dx. Now we can take yx naught that side, so we will get yx is equal to yx naught plus x naught to x f of xy dx. We know that y of x naught means y naught. Therefore y of x is equal to y naught plus x naught to x f of xy dx. Let us take it as equation number 2. To get the first approximation, what we will do? We will put y equal to y naught in f of xy of equation number 2. To get the first approximation, put y equal to y naught in f of xy of equation 2. We will get yx is equal to y naught plus x naught to x f of x comma y naught dx. So this is the first approximation. This first approximation you can write it as y of 1 is equal to y naught plus x naught to x f of x comma y naught. Now to get the second approximation, put y equal to first approximation of y in f of xy of 2. So what we will get? Second approximation of 2 is equal to y naught plus x naught to x f of x first approximation of y dx. Similarly, we can get the third approximation. Similarly, the third approximation y3, that is the third approximation of y, is given by y3 is equal to y naught plus integration x naught to x f of x second approximation of y dx. Continuing this process, we obtain a sequence of functions. First approximation of y, second approximation of y, third approximation of y, and so on. Each function gives a better approximation to the solution than the preceding one. We will continue this process and we obtain a sequence of function, first approximation of y, second approximation of y, third approximation of y, and so on. And each of this function gives a better approximation to the solution than the preceding one. So y2 gives a better approximation than y1, y3 gives a better approximation than y2, and so on. Now let us find a numerical solution to first order ordinary differential equation using Picard's method. Now let us look at this problem where we need to use Picard's method to obtain a solution up to third approximation of the equation given by dy by dx is equal to x plus y. y0 is 1, that is the initial condition, and we need to find yx for x equal to 0.1 and 0.2. Given dy by dx is equal to x plus y, and initial condition is y0 is equal to 1, x naught is 0 and y naught is 1. This equation you can write it as y dash is equal to x plus y. Let us take this equation as equation number 1. This successive approximation by Picard's method is given by nth approximation of y is equal to y naught plus x naught to x, f of x comma n minus 1th approximation of y dx. Now let us take it as equation number 2. To get the first approximation, we will put n equal to 1 in equation number 2. For first approximation, put n equal to 1 in equation 2. So we will get y1 is equal to y naught plus integration x naught to x f of x comma y naught dx. Now let us put the values of y naught and x naught. Y naught is 1 plus x naught is 0, 0 to x f of x comma 1 dx, which we can write it as equal to 1 plus 0 to x f of x comma 1. We have that dy by dx is equal to x plus y, that is equal to f of x comma y. So if f of x comma y is x plus y, so f of x comma 1 will be x plus 1 dx. Now let us integrate this. We will get 1 plus x square by 2 plus x, and 0 to x are the limits. So if we put the limits, we will get 1 plus x square by 2 plus x. If you put 0, it will give you 0. Now we will find the second approximation. For second approximation, put n equal to 2 in equation 2. We will get y of 2, that is second approximation of y, equal to y naught plus x naught to x f of x comma first approximation of y dx. Now let us put the values. Y naught is 1 plus x naught is 0 to x f of x comma y1 is 1 plus x square by 2 dx. Okay, so we will get 1 plus f of x comma this is y, integration 0 to x, f of x comma y is x plus y. So f of x comma 1 plus x square by 2 will be x plus 1 plus x square by 2 dx. Now let us integrate this. 1 plus x square by 2 plus x square by 2 plus x cube by 6, and limits are 0 to x. So we will get 1 plus x plus 2x square by 2 plus x cube by 6. If you put 0, it will give you 0. Therefore, second approximation of y is 1 plus x square plus x cube by 6. We need to find till third approximation. For third approximation, put n equal to 3 in equation 2. We will get y3, third approximation of y, is equal to y naught plus integration x naught to x f of x comma second approximation of y dx. Now let us substitute the values. Y naught is 1 plus integration 0 to x f of x comma second approximation of y is given by this 1 plus x square plus x cube by 6 dx. We will get 1 plus integration 0 to x f of x comma y is x plus y. It will be x plus 1 plus x square plus x cube by 6. Now let us integrate it. 1 plus x square by 2 plus x square by 2 plus x cube by 3 plus x 4 by 4. Here 6 is there, so it will be 24. And the limits are 0 to x. So we will get 1 plus x plus 2x square by 2 plus x cube by 3 plus x 4 by 24. Therefore, third approximation of y is given by 1 plus x square plus x cube by 3 plus x4 by 24. So this is the expression that represents y of x, because we need to find the third approximation. Therefore, y of x is equal to 1 plus x square plus x cube by 3 plus x4 by 24. Now we need to put x equal to 0.1 and 0.2. Put x equal to 0.1 and x equal to 0.2. We get y at 0.1 will be equal to 1 plus 0.1 plus 0.1 whole square plus 0.1 whole cube by 3 plus 0.1 whole power 4 by 4, which is equal to 1.1103. Now putting 0.2, we will get 1 plus 0.2 plus 0.2 whole square plus 0.2 whole cube by 3 plus 0.2 whole power 4 by 4 is equal to 1.2427. Therefore, the required solution is given by y at 0.1 is equal to 1.1103 and y at 0.2 is equal to 1.2427. So this is how we solve first order ordinary differential equation using Picard's method. Now look at this second problem where we need to find an approximate value of y when x is equal to 0.1 and the given equation is dy by dx is equal to x minus y square and the initial condition is y at x equal to 0 is 1. We need to solve this using Picard's method. Here number of approximations is not mentioned. So let us see how we can solve this. Given dy by dx is equal to x minus y square and initial condition is y at 0 is equal to 1, which means x naught is 0, y naught is 1. This equation you can write it as y dash is equal to x minus y square. Now we will use the Picard's approximations. By Picard's method, we have the nth approximation of y is equal to y naught plus integration x naught to x f of x comma n minus 1th approximation of y dx. Let us take it as equation number 1. Now to get the first approximation, we will put n equal to 1. For first approximation, put n equal to 1 in equation 1. We will get first approximation of y is equal to y naught plus integration x naught to x f of x comma y naught dx. Now let us put the values. Y naught is 1 plus integration x naught is 0 to x f of x comma 1 dx. We will get 1 plus integration 0 to x f of xy. Since dy by dx is equal to x minus y square, which is f of x comma y. So here f of x comma 1 will be x minus 1 square, that is 1 dx. Okay. Now let us find the integration. 1 plus x square by 2 minus x. Limits are 0 to x. We will get 1 plus x square by 2 minus x, which is first approximation of y. Now let us find the second approximation of y. For second approximation, put n equal to 2 in equation 2. We get second approximation of y equal to y naught plus integration x naught to x f of x comma first approximation of y dx. Now let us substitute the values. Y naught is 1 plus x naught is 0 to x f of x comma what is y1? 1 minus x plus x square by 2 dx. So we have 1 plus integration 0 to x. Here f of x comma y is x minus y square. We will get here x minus 1 minus x plus x square by 2 whole square, and this is dx. So we will get 1 plus integration 0 to x minus, this is a plus b plus c whole square formula, a square plus b square plus c square. It will give you x 4 by 4 plus 2ab. That means 2 into 1 into minus x minus 2x plus 2bc. 2bc means 2 into minus x into x square by 2. So we will get minus of 2x cube by 2 plus 2 into x square by 2 dx. Since a plus b plus c whole square formula, a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Okay. Now let us simplify it first. 1 plus 0 to x minus 1 minus x square minus x power 4 by 4 plus 2x plus x cube minus x square and dx. Let us integrate it now. 1 plus x square by 2 minus x cube by 3 minus x 5 by 5 and here 4 is there, so it will be 20 plus 2x square by 2 plus x 4 by 4 minus x cube by 3 and the limits are 0 to x. So we have 1 plus x square by 2 minus x cube by 3 minus x 5 by 20 plus x square plus x 4 by 4 minus x cube by 3. If you put the limit as 0, you will get 0. Let us now rearrange it. 1 minus x plus 3x square by 2 minus 2x cube by 3 plus x 4 by 4 minus x 5 by 20, which is the second approximation of y. Now you look at this term. To find the third approximation, we need to put this and we need to find the square. So it is difficult to find the integration if we substitute this value in the integration. That's why we will stop this process and we will say this is the yx. Since calculation of third approximation of y is difficult, we stop this process. Therefore, yx is given by 1 minus x plus 3x square by 2 minus 2x cube by 3 plus x power 4 by 4 minus x power 5 by 20. Now we put x equal to 0.1. So we get y at 0.1 is equal to 1 minus 0.1 plus 3 by 2 into 0.1 whole square minus 2 by 3 into 0.1 whole cube plus 0.1 power 4 by 4 minus 0.1 power 5 by 20. If you compute this value using calculator, you will get 1.1144, which is the required answer. So this is how we need to find the approximate solution of ordinary differential equation using Picard's method. Thank you.